a monoatomic gas at a pressure P having a volume V expands isothermally to a volume 2V and then adiabatically to a volume 16V. The final pressure of the gas is. Now, first they are going to given here isothermally. In isothermal, we know that P1 V1 is equal to P2 V2. And they are given, it is a P1 V1, it is a P and V is equal to P2 and volume is a 2 times of V. That is 2 times of V. Then if I get cancel this V and V, then P2 is equal to P divided by 2. Then what happened in the process we will observe here. Okay, firstly it is in the isothermal process, that is from P1 to P2 at constant, what the isothermal means, constant temperature. Then this is a P2 here and the process is isothermal process. And then adiabatical process, then it is the up to P3, then this is adiabatic process. P2 V2 to the power of gamma is equal to P3 V3 to the power of gamma. And P2 is nothing but P by 2. I will substitute the direct value. P by 2 times 2V to the power of gamma is equal to P3 into 16V to the power of gamma. Then P3 is equal to P by 2 into 2V divided by 16V whole to the power of gamma. Then P3 is equal to P by 2 into, we can write this one as 1 by 8 and the gamma value they are given as 5 by 3. Then P3 is equal to P by 2 into, we can write this one 8 as 2 to the power of 3 to the power of 5 by 3. Then P3 is equal to P by 2 into 1 by 2 to the power of 5. Then P3 is equal to P into P by 2 into P by 2 into 1 by 32. Then P3 we get the value P by 2 into 32 is 64. The final pressure of the gas is P by 64. That is option C is the right answer.